In this video, we're going to talk about how to graph the variations of cosine. Now, what's really nice about this is that is very similar, almost identical to graphing sine variations. So, we know that the parent function of cosine is just cosine of x, but we can do a lot more with that. We can multiply it by a. We can multiply that x by a number. We can subtract something inside the cosine, and then also add or subtract something on the outside. And all these things are exactly the same as it is for the sine variations. The a stands for our amplitude. We have to find the absolute value of whatever that number is. The period of a cosine function is usually 360, but to find it on a variation, we just take that and divide it by whatever b happens to be. We have our phase shift, which is our left or right movement. Everything on that graph is going to shift left or right, and that is c divided by b. Remember, the c value is opposite of what we see. And then, of course, our vertical shift is going to be whatever the value d is. So that's going to be up or down, the entire graph moving up or down. So, here's our example. Now, if we notice here, -3, that'll be our a value, 360 is b, and the 2 at the end is the value for d. That means there is no c value here. So that's actually going to help us out. We're only using 3 of the 4 variations that we have. Now, I will point out something. Right here, what's in parentheses. We actually don't need those parentheses. So if you ever come across something like this, it is implied that 360x is part of the cosine. What might confuse people is when they see it without parentheses, they might think the +2 is actually the value of c, but it's not. The only time there's a c is if there's parentheses around that addition or subtraction. So this is what we have, or I don't even need the parentheses. It means the same thing. If you don't see parentheses, but it helps you, just go ahead and add them. That's what I like to do. So going through these, this is going to be the exact same steps as it is for sine. Only difference is when we substitute this stuff into our calculator, we're going to press our cosine button. Make sure you are in degrees on your calculator. So our amplitude, the a value is -3, so our amplitude is actually 3, meaning when we graph this, wherever our baseline is, from there to the maximum should be 3 units. Next, we have the period or the cycle. How long should that be? It's usually 360. And now we get to divide it by our b value, which happens to also be 360 this time. So the period is actually just 1. That's not a lot. That means from wherever we start, it's going to be 1 more degree from that. It's actually a really, really small, very compressed graph. And then we have our phase shift, which is c divided by b. The value of c is not here, which means it's a 0. So our phase shift doesn't exist. We're actually not moving. What's really nice, phase shift tells us where to start. You can always write yourself a little note there. And then our vertical shift is just that last value, which is 2. And since it's positive, everything in our graph is going to move up 2 units. And I will also mention that this -3 here, if that first value happens to be negative, it means the entire graph is going to flip. So usually our cosine graph looks like this. With that flip, it's going to look like that. So kind of a quick check for us there. All right, the next thing we need to find are our 5 key points. Now remember, on a cosine graph, we have those 5 key points, and that cuts that into our quarters, which, just like sine, means we need to take whatever the period is, the whole length of it from start to end, and cut it into quarters, divide it by 4. Which means our period this time was just 1 divided by 4. So actually we're just going to add a quarter to everything. Our first key point was whatever our phase shift was, which was 0. To find our second, we take the previous value and add whatever that quarter value was, which is a quarter. So that's our second number. Our third key point, we're going to take that previous value and add the quarter again, which will be a half. And keep doing that again. Add the quarter until we get 5 key points. So 0, a quarter, a half, 3/4, and 1. Those are our 5 key x values, which means now we need to find all the corresponding y values. So I like to make this chart. So our first key point, key x value, was 0. And all we're going to do is substitute that value in for x into the equation that was given. So it's 360x, but now we're actually multiplying it by 0 instead of x, and so forth. Now you can type this whole thing straight into your calculator and get your answer. Also probably good to maybe take a few steps. We know 360 times 0 is just 0. The cosine of 0 is actually 1. -3 times 1 plus 2 is actually -1. So that's one of our coordinates. 0, -1. And we do that with the next one. Next we have a quarter. You substitute. And solve. 360 times a quarter is technically 360 divided by 4, and that's 90. The cosine of 90 is actually 0. -3 times 0 plus 2 is 2. So that's our next coordinate. And keep doing that until you have all 5 coordinates from your key points. Okay, after you find all the coordinates, these are what you should have. These are our 5 key points. Now, if you notice, the first and last one are the same, as well as the second and the fourth. The second one and the fourth one is going to be our baseline, what's in the middle. So this should pretty much always happen. Can't think of any times when they wouldn't, where the first and last would be the same as well as the second and fourth. And then from here, all you need to do is graph. Now this time, my x values need to go all the way up to 5. And down to -1. And if you look at our x coordinates, it needs to start at 0 and go all the way to 1. And we need our quarters just right there. And then we just need to graph them. After we have all the points, we need to connect them. Now this is what a lot of people do here, is they just make this V because it kind of looks like a straight line. Do not do that. Remember, it's actually a curve, and it'll look better on Graph Paper if you don't, or if you can't print off the assignment. Make sure you use a straight edge. Maybe even get a ruler and measure these out. So yeah. And then remember, our baseline is going to be right here, and we said our amplitude was 3. So between the maximum and that line should be 3, which 1, 2, 3, it is. So there's our amplitude, and we can also check that going the other way from our baseline down to these other points here. That should also be 3. So 1, 2, 3. That's the amplitude as well. So kind of those quick checks there, which is really, really nice.